Okay, let's see with electrical analog of mechanical translation system. This electrical analog of mechanical translation system coupled with the motor and load dynamic facts. Okay, first block says mechanical system of translation. This mechanical translation system can having three elements. That elements are mass, dashport, spring. Across that electrical system having three elements. That elements are resistor, inductor, capacitor. So those two variety of six elements can coupled and analog with this electrical and mechanical body systems. Okay, next we can communicate the letter representation of mechanical translation system and electrical system. This mechanical system of letter representation is M, B, K. K is stiffness or spring, M is mass representation, B is dashport representation. Then electrical system, according to the electrical system, resistor representation is R, then inductance is L, capacitance is C. So those six elements have to rotate the analogy type, that is mechanical translation, and electrical analogy type. Then we can move with the mechanical rotational system with the electrical analogy. Mechanical rotation system always shows three different kind of differential elements apart from the translation system. The differential elements are moment of inertia, spring, and dashport. Same like dashport representation letter is B, spring is K, moment of inertia J. Same as electrical system or resistance, inductance, capacitance. So those 9 components are very essential for supporting this analogy system. First we have to see the example problem. This problem are differential equation governing of mechanical system with the electrical analogy. Okay, just I have to show you the various zonal of the force current electrical analog circuit. This is black diagram representation of analog system. This problem doesn't mean which is a mechanical translation system, but we have to define or identify this problem is a mechanical translation. How does it mean? It contains two mass body M1 M2, two springs K1 K2, two dashport B1 B2, and all those things of mechanical translation related displacement and force are there. So this problem is exactly mechanical translation problem with the analog of electrical system. So we immediately begin with the mechanical translation steps. We make that two mass body M1 M2 adopted with two different differential equation combined on the connected across the differential elements of self opposing force Fm1, dashport Fb1, and stiffness Fk1 with the help of displacement and applied voltage. Okay, so we got the differential equation from that M1 mass, M1 d square x1 dt square plus b1 d into x1 minus x2 by dt plus k1 x1 minus x2 equal to 0, because there is no input force across that M1. Then we move with mass M2. So M2 mass, outline of that M1 mass is inbuilt of that M2. So all of the element can connected across or inbuilt of this M2 mass. Always I am saying each and every mass having self opposing force. That opposing force for M2 is Fm2. Apart from the Fm2, Fb2, Fb1, Fk2, Fk1 are connected towards this M2 mass. So make this connection, we make the differential equation across them. Depends those differential equation and adopted the electrical analogy circuits. So we just replace those differential equation elements of electrical C1 dV1 by dt plus 1 by R1 V1 minus V2 plus 1 by L1 integration of V1 minus V2 into dt equal to 0. This is first differential equation. There is no input force across it. In second differential equation, we replace that electrical analogy of mechanical translation system. We got C2 dV2 by dt plus 1 by R2 V2 plus 1 by L2 integration of V2 dt plus 1 by R1 V2 minus V1 plus 1 by L1 integration of V2 minus V1 into dt equal to I of t. Because it has input force f of t, so we just substitute f of t into I of t. We make these two force current analogy circuit to the circuit given by we make that electrical analog system. Okay, this is conclusion of this problem. First we have to define two differential equation. After that, for those two differential equation adopted the electrical analogy. Finally, we make the one electrical equivalent circuit for that analogy equations. That's it.